Hi, in this video I'm going to discuss about the replacement model under the category of individual and group replacement and replacement of items that fails suddenly. So before we are going to solve the problem, so we must know the background theory of individual and group replacement. Let us assume a system consists of n number of parts. If any one of the part fails suddenly, so we have to replace the part immediately, so in order to bring back the system in the original condition or previous condition. So first we will discuss about the individual replacement. So let us consider that a small part in a system, that small part is failed suddenly and it is to be replaced immediately. So the cost of the part I am explaining with an example. Cost of the part equal to 100 rupees 100. So without this part the system cannot able to work, so it is necessary to replace the part immediately. So the cost of the part is 100 rupees, and unfortunately, so this part, specifically this part, is not available at the local market. So we have to buy this product from somewhere or out of the city or some other city. So it requires some amount of money, which means the traveling cost, I'm telling for an example, traveling cost will be 200 rupees, and some other expenses will be equal to another 100 rupees. So a person has to go to another one city, and he has to purchase the particular part, and he has to come back to the organization or the plant and fit in the system, and the system has to be function as usual. So the original cost of the part will be 100 rupees, but the total expenditure will be total expense equal to 400 rupees, which is 4 times of the uh, original cost of the part. So the organization does not have the particular part in their inventory because they don't know that part will fail suddenly. So that part has been failed suddenly without giving a signal or without giving any warning. So it is to be replaced immediately. So because of the sudden failure, the total expense will be 400. This is for a specific part, so that part only has to be replaced. So this is individual replacement model. So in individual replacement model, even though the cost of the part is 100 rupees, the total expenditure becomes 400. So in individual replacement policy, the total expenditure will be very huge. Okay, so now we will discuss another one model, that is replacement. Group group replacement. So group replacement means, based on some statistical data, based on some experience, um, the average life of a group of products. For example, in an organization there are 100 electrical bulbs. The based on some statistical data or experience, the responsible person finding that the average life of all the bulbs will be 4 months from the installation. But so unfortunately, at the end of a first year, 10 bulbs has been failed. So that 10 bulbs has to be replaced immediately, because all the bulbs are installed at the same time, and all the bulbs must be replaced at the same time. Okay, after 4 months all the bulbs must be replaced, even though they are working or not working. So In the group replacement, it has two kinds of cost, because at the end of first month 10 bulbs has been failed, so that 10 bulbs immediately has to be replaced. So that is individual replacement. So the group replacement cost equal to individual replacement cost plus group replacement cost. So it has two kinds of cost. First is, one is individual replacement cost. So at the end of a first year, that particular 10 bulbs must be replaced. So let us assume at the end of at the end of first month, let us assume at the end of second month, another 20 bulbs has been failed. So that 20 bulbs has to be replaced immediately. And at the end of third month, so another 10 bulbs has been failed. So that bulbs also has to be replaced. So these are all comes under the individual replacement. So at the end of a fourth month, all the bulbs must be replaced by a new one. Even though some bulbs are working properly, the replacement has to be taken place based on the replacement policy. So at each month, the failed components must be replaced, and after a certain period, after the average life of the component, all the component or all the parts of the machine or an item has to be replaced as a group. So that group replacement is having two kinds of cost. One is individual replacement cost and another one is group replacement cost at the end of average life of the product. So the group replacement cannot be operated individually, so separately. So it has to be manipulated along with the individual cost. So the decision maker or the plant manager or the responsible person has to take a uh, proper decision whether the individual replacement is better or the group replacement is better. So now we are going to solve a problem which deals with these two replacement policies. Okay, so let's go to the problem. So this problem is comes under the category of replacement of items that fails suddenly with the condition of individual and group replacement policy. Let me dictate the problem statement. A system consists of 10,000 electric bulbs. When any bulb fails, it is replaced immediately, and the cost of replacing a bulb individually is rupees 1 only. If all the bulbs are replaced at the same time, that cost per bulb will be rupees 0.35. The percentage surviving and the probability of failure during the month T are given in the table. Find the optimal replacement policy. So in the statement we can able to see that there are two kinds of replacement policies. One is individual replacement policy and another one is group replacement policy. So in two cases the bulbs are replaced. In the first case, so when the bulb fails, it is replaced by a new one that comes under individual replacement policy. And after certain time, all the bulbs are replaced as a group. So that is group replacement policy. So um, the percentage surviving and the probability of failure in each month is given in the table. So 0, it means during the installation or at the starting of installation of all the bulbs, the probability of surviving is 100% and the probability of failure will be 0. There is no failure at the starting. At the end of first month, the probability of surviving will be 97% and the probability of failure will be 0.03. And in the second month, the probability of failure will be the probability of survival will be 90% and the probability of failure will be 0.07. So this probability also can be expressed in the terms of percentage. So we can say this is 3%, 7%, 20%, 40, 15, 15, like that. Okay, so the data are given for 6 months. So as I said earlier, this problem consists of two kinds of replacement policies. One is individual and another one is group. So first we have to encounter the individual replacement policy, and then we have to proceed with the group replacement policy. First we will proceed with the individual replacement policy. Individual replacement policy. Okay. So as per the given data, or as per the problem statement, uh, no bulb will survive after 6 months. So because the probability of survival at the end of 6 months will be 0, so after 6 months all the bulbs will be failed. Okay, so no bulb will be survived after the 6 months. Now let us assume n naught is the number of bulbs at the beginning. Number of bulbs at the beginning, and n1 is the, and this number of bulbs at the beginning will be 10,000, which is given in the problem statement. So at the end of first month, so number of bulbs n1 is the number of bulbs replaced at the end of first month, equal to number of bulbs at the beginning into probability that a bulb fails during the first month. So which means that n naught into probability of failure in the particular month. So it can be written as 10,000. N naught is the 10,000, and P1, the probability of failure at the first month, equal to 0.03, which is equal to 300. So in individual replacement policy, at the end of a first month, among the 10,000 bulbs, 300 bulbs will be failed. So n2 is the number of bulbs replaced at the end of second month. So follow uh, this pattern. Like, I'm going to rewrite this formula like n naught into p2 plus n1 plus n1 into p1, which is equal to, so n naught is 10,000 into p2 is probability of failure at the second month, that is 0.07, plus N1 equal to 300 into P2 will be, sorry, P1 will be 0.03, which is equal to 709. So 709 bulbs will be failed after the or at the end of second month. For third month, the formula can be manipulated like so. For third month, so N0 into P3 plus N1 into P2 plus N2 into P3, sorry, P1, that's it. So see the pattern, the N terms are getting increasing and the P terms are getting decreasing, so we can easily remember. So N0 will be 10,000 into P3 will be 0.20 plus N1 will be 300 into P2 will be 0.07 plus N2 will be 709 into P1 will be 0.03, so which is equal to 2042. For fourth month, N4, that is equal to, so continue the same pattern, so which becomes, so N0 into P4 plus N1 into P3 plus N2 into P2 plus N0, sorry, P2, sorry, N3 into P1, which is equal to, so N0 will be 10,000 into P4 will be 0.4 plus N1 will be 300 into P3 will be 0.20 plus N2 will be 709 into P2 will be 0.07 plus N3 will be 2042 into P1 will be 0.03, which is equal to 4171. Similarly, the formula for N5 equal to N0 into P5 and n1 into p4, n2 into p3, n3 into p2, plus n4 into p1, 4 into p1, which is equal to n0 will be 10,000 and p5 will be 0.15 and n1 will be 300, p4 will be 0.40 and n3 will be 709, sorry, n2 will be 709 and p3 will be 0.20 and n4 will be, sorry, n3 will be 2042 and p2 will be 0.07 plus n4 will be 4171 into p1 will be 0.03, so which is equal to 2030, so n5, and then so I'm going to copy the terms. So for n6 the formula is n0 into p6, n1 into p5, n1 into p4, n2 into p4, n3 into p3, n4 into p2 plus n5 into p1, n5 into p1, so which is equal to n0 equal to 10,000, p6 is 0.15 and this is also 0.15 and this is 0.40, this is 0.20 and this is 0.07 plus 2030 into 0.03, which is equal to 2590 bulbs. So this is the individual replacement policy values for each month. Okay, so, right, now we have to find out the average life of bulbs. Average life, so the average life equal to, so we have to multiply the particular month into particular month probability. So for the first month the probability will be 0.03 plus for second month the probability is 0.07 plus for third month the probability is 0.20 plus the fourth month the probability is 0.40 plus for fifth month the probability is 0.15. For 6 month the probability 0.15, okay, which is equal to 4.02 months. So average life of each bulb will be 4.02 months. Okay, now we have to find out average number of replacement in every month. Shortly I will write it as average number of replacement in every month equal to, so the initial value 10,000 divided by average life of each bulb 4.02, which is equal to 2488 bulbs, which means on an average every month, so the organization has to replace 2488 bulbs based on the individual replacement policy. So we have to find out the individual replacement cost. To find out the individual replacement cost. So in the cost, so there are bulbs 2488 per month, and cost of each bulb will be 1 rupee based on individual replacement policy. The total cost per month will be 2488. So individual replacement cost per month. Okay, so highlight this value, it will be required later. So next we will discuss about the group replacement policy. So make a table like this. So make a table like this. So in the first column, so it is filled with month. The second column, so we have to find out the total cost per month based on the group replacement policy, and the third column, average cost per month. Okay, so as I said earlier during the theory part of this group replacement, so the total cost of group replacement policy consists of two costs. One is individual replacement cost and another one is group replacement cost. So we have to manipulate these two costs. First month, take the first month, the cost of individual replacement will be so we can able to see that, so n1 number of bulbs failed at the end of first month will be 300. First month will be 300 into the replacement of each bulb cost will be 1 rupee. So based on the individual replacement policy plus group replacement. So group replacement means at a time we are replacing all the bulbs. So let us assume that at the end of first month all the bulbs will be failed and we have to replace all the bulbs at the end of first month, even though the average life of bulb will be around 4 months. So we are assuming that the bulbs are replaced at the end of first month. So that group replacement cost will be 10,000 into cost of replacement of bulbs based on the group replacement is 0.35. 0.35. So the total cost will be 3,800. Okay, and cost per month, so 3,800 divided by 1 equal to 3,800 in rupees. For second year, the individual replacement cost. So for second year, the failed bulb will be 300 in the first year and 709 in the second year. So into 1 plus, so we are assuming that all the bulbs will be replaced at the end of second year. So into 0.35 is equal to 4,509, and the cost per month will be 4,509 divided by 2 equal to 2254.5 rupees. And so at the end of third year, the failed bulbs at the end of third year will be 300 plus 709 plus 2042 into 1 plus, so we are assuming that all the bulbs will be failed at the end of the third month, so the total cost will be 6,551 and the average cost will be 2,183. So at the end of fourth month, the failed bulb will be based on individual replacement policy, 300 plus 709 plus 2042 plus 4,171 into 1 plus, so we are assuming that all the bulbs will be failed at the end of fourth month, so the total cost will be 10,722 and the average cost per month will be 2,680.50. So at the end of the fifth month, total failed bulb will be 300 plus 709 plus 2042 plus 4171 plus 2030 into 1 plus, so we are assuming that all the bulbs will be failed the end of fifth year, so it takes the cost of 10,000 into 0.35 and the total cost will be 12,752. The average cost per month will be 2,550.40. So at the end of sixth month, the failed bulbs will be 300 plus 709 plus 2042 plus 4171 plus 2030 plus 2590 into 1 plus, so all the bulbs will be failed the end of sixth month, so the total cost will be 15,342 and the average cost will be 2,557. Okay, so almost the problem is over. Okay, so from the table, so look at the value The minimum cost per month will be 2183. So this is the least cost to replace the uh, bulbs based on the group replacement policy. So the minimum group replacement cost, minimum the minimum group replacement cost equal to rupees 2183. Okay, based on the group replacement policy. But based on the individual replacement policy, individual replacement cost per month will be rupees 2488. So which is less than the 2488 based on the individual replacement policy. So the decision maker can choose the group replacement policy, and it is economical to replace all the bulbs at the end of third month based on the group replace policy. So the group replacement policy only gives the minimal amount of cost to replace all the bulbs. So up to this the problem is over. So practice a similar problem, so based on these procedures. Thank you.